Assalamualaikum and very good afternoon. Uh, I think this may be a follow-up from earlier this morning discussion where we talk about IR 4.0 and IoT. I think this word is already a buzzword since quite some time ago, but unfortunately, some of us might be have some difficulty on certain parts when we want to deploy or implement our strategy to deploy an IoT infrastructure. So let me take a look because maybe some of you have heard about this very much earlier. It depends on where you are. If you are from the academic world, most likely you have been doing this for many years. And but some people from the consumer side, from the public themselves, or even from the business, they might just heard this quite recently. It is, if you take a look, for example, IoT themselves have been coined by Kevin Ashton. So we consider him as the father of IoT, Internet of Things. That was sometimes in 1999. He was working with Procter and Gamble. So he thought that there must be a better way to check the stock level in the store, especially the lipstick, what kind of colors that needs to be restocked and so on and so forth. So they were working on RFID. So that's when the first IoT devices that being used at that time was RFID. So it's an identification. So you will know exactly where the device are. But to some of you, if you want to know whether when exactly that Malaysians, for example, here in Malaysia, if you take a look at Google Trends, you take a look at Google Trends and you keep in IoT and you look at the whole 5 years, you can see that Malaysians start to Google IoT in 2014, right? So at that time, we were trying to grasp the idea of what IoT is all about, and now you have seen the trend is growing up. So people have been searching a lot of words about IoT. But the word Industrial Revolution 4.0 is still very new. Maybe because we have launched the Industry Forward, which is sometime end of 2018. That's when people also start to search what exactly is IR 4.0. So IoT have been coined in 1919, but in 1999, but we only start to Google in 2014. And IR 4.0 have been as early as 2014 in World Economic Forum. But yet, maybe we are a little bit late. About 2018, we start to understand what the fourth industrial revolution is. Okay, so why is it important? These two components. If you look at, it's all about digital transformation, and organizations need to reinvent themselves. So they need to know what are the trends of technology that's coming in and disrupt their business. So if they are not able to reinvent themselves within that 3 to 7 years period, because the cycle of technology is very fast, so then they will become obsolete. And Boston and Consulting, for example, have seen that the last 50 years ago, the companies that still in existence today is only 19%, and most of them have already obsolete. So that is the fast pace of a technology. I think even us, we have been using products which is still a very old products, but I'm not sure whether you are still using that or not. Okay, so technologies like this have changed the way that we live. Cameras, the one that even the younger generations don't know how to take cameras using Kodak, for example, in a film. Yet they haven't seen, some of them haven't seen even cassette tape recorder, and we have changed that into Spotify, the way that we stream the radio, stream the music, and the way that we watch videos. You still remember the VHS times. So now we have been using YouTube, we're using Netflix. These are all digital information that have been transformed, right? So a lot of these things is that have disrupt the way that we do things. Now a phone itself have taken the jobs of many things. A phone itself is not only for voice communication, it's meant for many other things, for your entertainment, for your work, for your communications purpose. Everything is now converged into one single device. That's the impact of technology. And because of that, this technology comes in ripples. Every technology have their own ripples, and slowly these smaller ripples, when they combine, it become a bigger ripples, and we can consider that a tsunami. So a tsunami happens when there is, a sudden surge where you can see on from far. It's only a very small wave, but as it goes to the beach, you will see the ripple becoming bigger and become a big tsunami. And for most people who are not aware, who doesn't care about the small ripples, they didn't realize that the tsunami will hit them. So this is what happened when we are too complacent, and when we feel that we are so comfortable with what we have now. So internet itself has three kinds of tsunamis that we are facing. The first tsunami is on always is mentioned that it's always on desktop on fixed internet. But now since mobile, so we are using all the phones that we have now is internet in the pocket, let's say, so mobile internet. But what we are facing, the third tsunami, is when all the things that you can imagine of can be connected to the internet. So why exactly that we need internet of things? Why things needs to be connected? So for some of you who might be not aware about exactly what IoT, because a lot of misconceptions, people have perceived differently about IoT itself. So, but generally, IoT have four main components that you guys need to remember. The main component, the first component, it must have sensors. It sense. So all the human sensors that we have, humans have five senses. And some of you might have six sense, I would say. So these sensors are now being turned into digital. So temperature, humidity, location, pressure, gas, camera, mic, and all of that are all turned into digital sensors. And many phones nowadays, even your phone have many sensors in there, more than 10, sometimes 20 sensors inside your phone itself. So these sensors are the basic component. And then there are actuators, the one that react to the information that you have, so it can control things. So secondly, it must have connectivity. You must find a way for you to connect to the internet. So it's a way for you to send your data out. So it can be a fixed network on fiber or whatever, but the initial connection, the first mile connection or the first device, how it connects mainly through wireless. So wireless can be in many forms. I think you guys know that there are different kind of wireless. If you are trying to connect, which is very near to you, you might have what we call the body area network. So body area network is the one that we can connect using RFID, NFC. So it's very close to you. So there are devices which you cannot go far, they cannot connect things. So normally you have to, they need to touch it or very near to the. Secondly, you might have like local area network. You might have like Zigbee. You might have Bluetooth. You might even have Wi-Fi. So this can send data up to maybe 50 to 100 meters. So there are things that you want to connect further, then you use whatever network that is out there now, the 3G, the 4G, and now the current 5G. And of course, the new network of IoT, they have what we call LP1. LP1 stands for a low-powered wireless area network. So the three famous networks that you might see here in Malaysia is like LoRa, long-range network, and then we have Sigfox, and then we have NB-IoT. And LoRa, normally you can do this, you can implement by any private companies, organizations, or your labs, you can implement LoRa because it runs on ISM band, 2.4 gigahertz. So it's an unlicensed band, so you can do that. But then on like NB-IoT is mainly by the telco themselves. So they use their license infrastructure, spectrum, to send the data out. So LP1 have a better in terms of range, the coverage. It has smaller packets. It can send small data. And the device that use LP1, NB-IoT, Sigfox, or LoRa, they are can save a lot of battery. So that doesn't consume a lot of battery. So that's why a lot of IoT deployment, which sends small data, require a cheaper version. That's LP1. So the current way of doing things is using cellular. So you are use either 2G, 3G, 4G, but it's quite expensive. So the previous way of sending data on M2M is normally on GPRS, on 3G. So sometimes the cost is like 15 ringgit per month. Whereas when you are sending data, it's very small and infrequent data. So it's not cost economically. So the third part is, how do you save and process the data? Where do you save your data? Because a lot of times the data, when it's sent from the sensors, it has different protocols. So it might be sending through MQTT, it might send through REST, it might send through CoAP protocol. So there must be a way, a platform that can receive the data, connect it, collect it, and aggregate it. Okay. So a lot of times you send REST protocol, HTTP type of protocol. So, but there are what we call that MQTT, which is you need a lot of IoT devices, which is battery based, use MQTT, and REST normally consume a lot of battery. So from there, the IT middleware is and what we call the IoT platform aggregates all the data that comes from many sensors. Right? So it can sit in the cloud or in the public or in the private customer's premise. And then what we have is that once we have all the data, what can we do with the data? So that's where the applications come in. Application can come in many forms. Either it's like a workflow process for business, for logistics, for monitoring. So, and then you have a dashboard, you have analytics engine. This is where all these components needs to be, beside here that makes meaning of the data. So you can collect all the data, but you have to make meaning of the data. So that is the four main components of IoT. So in a case, so when we say that IoT devices, how many IoT devices now in the world? So people have predicted that it can be uh, more than the number of people around the world. There are 8 billion people around the world. The number of devices can be more than 8 billion people or 1 to 1. But now they are saying maybe 6 to 1, 6 devices to 1%. So how many connected devices that you personally have? Right? Personally have. For example, like me, I have a phone that's a connected device. I have an iPad. I have a watch, wearable watch. I have a blood pressure which is wireless connected. I have my speaker, Amazon. I have Google Home. You might have even the lights. I have a lights in my house which is also wireless. I also have a weighing machine which I weigh every day, and the weighing machine tweets to the whole world stating that whenever I stand up on the weighing machine, it tells me the whole world, you are how many kilograms. So this is, when you collect all the data that you see, you will know the trends of your weight. This is my trend for the last 5 or 6 years. And then there is this device, which I have. I like to show you this device. They call Fokai. Okay, this Fokai, this device. So this device, what happens is that you can wear. Okay, the idea is this. What it is an intelligent device which have an artificial intelligence built into this device. It learns the breathing pattern. I have this problem of I call that focusing on my work. Sometimes when you're on the computer, there's a lot of other things interrupting you. So you cannot multitask. So it's not good. So sometimes you need to focus and understand how you can deep focus on your work, and also you need something that can alert you when you're not focusing on your work. So what it does is that you have to wear this on your belt. So it takes the breathing pattern, your breathing pattern, and learns your breathing pattern, and it will tells you whether you're focused, you are calm, you are angry, you are distracted. So that's how it can tells you, during that period of time, it tells you and advise you on that day, are you effective or not in focusing on your works. So this is something which is, so in that case, you can see how many devices that be connected that I have personally. So you might have some of this device with you. Okay. So now, when we talk about that relations, as now, when we talk about industrial revolution and IoT, why is it important? What's the relationship of IoT and the fourth industrial revolution? I think traditionally you will see that this is the normal slides that you have seen in the 1700s. You call that Industry 1.0. when all the things that you're doing is through mechanization, steam power. So this is the factory in during that era. So when the factory is being introduced use electricity, they have different way of producing. They have mass production, better use of manpower because they can use electrical machines and all that. In the 1900, you will see that industry 3.0 because we introduced electronics. So automation, computers, electronics are being used. In this era, we are using the current day, we are actually in the era of 4.0. So when we talk about 4.0, there's new technologies like IoT, the cyber physical world, AI, AR, virtual reality, augmented reality. This is today. But that is in the factory side. But fourth industrial revolution covers many aspects, not only in the industrial, in the factory, manufacturing sector, but everywhere. It goes across all verticals. So, for example, uh, we you can take a guess of where we are. So, if the things that you're doing nowadays is all about manual things, using your hands, some physical tools, that is 1.0. and and as I mentioned just now, when you introduce electrical, so your machines are electrical control, then it's 2.0. But the moment you use electronics, you use online, you use computers, you are using in the 3.0 thing. But in the 4.0 is when everything's become more intelligence. It's all about data. So you're collecting data. So through IoT, for example, and you use artificial intelligence, computational programming and all that to make meaning of the data. So you have AR, VR, blockchain. So these are the new technologies. So if you look like Malaysia, for example, so when we talk about industry forward, they have identified some of these technologies. So you can see big data analytics, AI, augmented reality, cybersecurity, IoT, autonomous robots. These are some of the technologies being defined in the industry forward. Industry forward in Malaysia is meant mainly for, I would say is that meant for manufacturing sector. Okay, so but if you look at different sector, they might have different pillars of technology. The one that can help them, which can focus that can help them. For example, I would say like the construction sector. Construction sector might have different enabling technologies. They have advanced building materials. They have prefabrication, modular construction. 3D printing is common. It's the same like industry forward. They might have building information system modeling, BIM. So across all the sectors. So now what we are seeing is that every sector, like construction, agriculture might have different pillars of technology. Healthcare, education might have different priorities of technology. So they might have their own framework or blueprint for this. Of course, the fundamental thing is all about data. I mentioned to you, it's all also for intelligence. Okay? So now, if I ask you, most of the time when I ask you, where where are we actually? Hmm? Where are we here in Malaysia in the era of industrial revolution? So before you answer that, let's take a look. If you can answer that on the Q&A lah. Just take a look at it. You can answer that in the Q&A session. All right. Okay. All right. So take a look. This is an example. I mentioned to you just now the 1, 2, 3, and 4. Right. So in the era of education, in the 1.0 era, is when you use blackboard. You use whiteboard. That is the physical part, and that's how you teach in the classroom. That's the era of 1.0. But now people have moved. When using electricity, you might use an OHP at that time, but still you use transparency to do that, right? So you have to display that on the screen. So it's quite tedious too. But then when you use online, you might have online teaching. And what we are doing now, webinar teaching and all that, is 3.0. So remember that we are still 3.0 in this era using online teaching, computers. But in the era of 4.0, as I mentioned to you just now, technologies like AR, VR, so these are the new technologies in the era 4.0. So in which era are we in when we are doing that teaching, education in your universities, in your classroom, in the schools right now? And you can see there's a big gap between the urban and the rural. Of course, I'm not sure whether you guys have been working even in 4.0 thing, right? So let's take a look. How about shopping? You can take a guess. You can answer that. Okay. So when you on 4.0 in shopping, remember the days when you use your cash, or even now today, you are still using cash and buku 35 to for IOU sort of thing, right? Remember that? Okay. In 2.0, you have cash machine. So this cash register. So you still use calculator to calculate how much that you buy and all that. And 3.0, you use credit card. That's 3.0. But when it's 4.0, you use like your smartwatch, you use like e-wallet and all that. And of course, you know that now we are using e-wallet. So in a lot of times, you are in the 4.0 in the shopping part. But there are cases, as I mentioned, in the rural areas, we are still using cash, right? So now let's take a look. The question is, where are we now? Can you take a guess? So is there an answer here? So take a guess. You can put that in your Q&A part. So you just remember wherever you go, you take a look. What I'm talking, you can answer that in the Q&A part. So when you are in construction, for example, let's take another further example, construction. So when we talk about construction, when we have a lot of people using manual labor, that's 1.0. When you have machines, the machines, electrical machines, it's only electric, doesn't have online, you are 2.0. When the machines are, when we are using computer, then we are 3.0. But, when you do ordering of your procurement process and all that, you are now 3.0. But when it's totally on using IoT to detect your safety of your labor, your workers, the condition of the assets, where they are. So now you're in the era 4.0. So in Malaysia, when we ask these questions, and most of us says that we are still at 2.7. 2.7 is that we are already electrical, but we have some elements of online. So there's a lot of businesses now in many places are still out of touch. Remember that they are not even connected online. So I'm sure that you heard just now early in the morning that we have been talking about online presence. A lot of organizations nowadays, uh, Dr. Zahab shows that the digital transformation of 2 years is being expedited within 2 months. So that's what the impact of COVID-19 is, because it's very difficult for you when you are being locked down. You have difficulty to do transaction physically. You need to find ways to do online, and we have seen the universities now, everything now to be online. So otherwise, you have very difficulty to do an education right now. But remember, when you're online, it's only 3.0. So to do more than 3.0, you have to put elements of augmented reality, teaching using virtual reality. So that's a good part. So Dr. Said says that you are in IR 4.0. Okay. So that is depends whether you yourself, but you look at the whole countrywide, the urban and the rural areas. Where are we? So now, then we talk about technologies like robotics and all that is becoming more and more scarier. This robotic is one of the elements of IR 4.0. You have seen they are taking jobs, for example, in the customer service. In SoftBank, for example, they use that for customer service. We have Sophia, who came over to Malaysia. She's the what they call Saudi citizen. Saudi give her a citizenship. So you never know. One day robots can take our citizens, because they are more easy. They are easily to be, I would say, to control rather than people with emotion, for example. So maybe they prefer this kind of citizenship. You look at Simon. Simon is the first robot. iRobot is like a ball that floats in the ISS. So rather than bringing in people to take notes and answer questions, they have this robot to record all this information which they have. So they save a lot of space when this robot is flying around the ISS. So they are taking the role of astronauts, for example. So because of that, so we have you have seen a lot of these animals, robots, and all that. So do you really think that robots can really take our jobs? So the automation part. So if you look at engineers, there are studies to show that no, it's least likely the engineers are going to be replaced by robots. Why? So that's the question. Then you take a look at medical practitioners. So it's least likely to be replaced by robots. But when you look at people who's using physical labor, so you can see that these are where the robots will take place. They will replace this kind of people. So there are I was sorry. So you get to look at this website, and you take a look and search your jobs, your career in the future, whether your likelihood to be replaced by this automation or not. Of course, if you take a look at robots, will take the jobs of the dirty jobs, the dangerous jobs, difficult jobs, right? The very repetitive things that you can't remember. Robots will do that. But of course, there are things which have very emotional, design, creative, and all that. That's where the robots have difficulty to replace you. So that's where most of these things we mentioned about talents, and we mentioned about the future jobs, they must have that kind of soft skills, because the hard skills most likely will also robots or AI can take that role too. Yeah. So what are the barriers? So if we see that, wow, this IR 4.0 is wonderful thing. Why are we so difficult for us to move fast? How can we move faster than before, right? So then we ask ourselves, okay, there are many barriers. One is because, again, like what Dr. Zahar mentioned earlier, is because of the mindset, the leadership part. They must have a very clear vision and mission. They must know the pain points of the organizations. So how to move, what are the trends that are coming in? Secondly, they must have talents, because these talents, the technology is coming very fast. They need to replace the older ones, the people who have old mindset, the people who are not willing to change. So you might have new talents, which is digital native, the people of the new generation. They are more willing to accept new technologies. Then you look at the champion that breaks down all barriers, because a lot of organizations, which is very big, they have difficulty to break the silos. So you must have a champion that can break down the silos. But the most difficult part is the fourth element, is the mindset transformation. But how do you change the mindset transformation? Yeah. So if you take a look, people are not willing to move is because they feel comfortable and they are scared to move to new things. If people like to do bungee jumping, that's what happened. They are comfortable to stand up, but they're scared to jump. So how do they make the first step? The easiest is to have that little push. So what is that formula of that push? So many times, a lot of us have been presenting in seminars, conferences, talking about the needs for digital transformation, but still very difficult for people to move until you see that, because we don't want them to sleep too long, because that's what happened when 3 to 7 years, if you don't transform, this is what happened. You're going to become obsolete. And that's when we need that wake up call. So this wake up call is the one that we have seen now recently, is the COVID-19. The COVID-19 is the best wake up call for many people. Now, CEO or CTO doesn't make that change, but the COVID-19 forced us to have a new norm. So at one time, telecommunication, they would say, telecommunication, what can we do with telecommunication? Now, telecommunication is one of the most important area. AI, data, machine learning. So these are the most important part nowadays, because now it's not more about physical part. So what we are seeing now, suddenly the ripples that we have seen, the wave that we are seeing from, since 1999, is very small wave, small ripple, and now becoming a big tsunami. So what happened is that there are few elements that make it a tsunami. As I mentioned, there are few technologies that comes on board of IoT. So for example, we talk about the hardware. The hardware is becoming more cheaper, more powerful. Yeah? The connectivity is becoming more pervasive. You go everywhere, you can get connected. Software development is very easy. The Moore's law, the transition double every 2 years. That's how the power of your phone is actually the same power that sent people to the moon. So now we have billions of phones. How many people that we can send to the moon? So then we have that Metcalfe's law, the network effects. So when everyone is connected, the effect is multiple. So the idea why these things must be connected is because we want to monitor the assets plus the environment, the surrounding environment. So this idea, for example, if you have goods, I need to know the question that most people will ask. I need to know and ensure that I can maintain the quality of my goods. Okay? A person, you yourself have an asset, which is the health. And you want to know, am I healthy? So that's a question that you want to ask. You have a house. You want to ensure that there's no intruder. If there is intruder, who is the intruder? If you have an asset, a bus in the university, you want to know when is the next bus coming in, for the bus. And then you have consumption of electricity. You want to know your bill. You have asset like the parking lot. You want to know where can I park? And the parking operator wants to know what is the utilization of the car park. So when you have all these assets, you need to find ways of these assets to be connected to you remotely. And this is where IoT is all about, right? So, and when people design product around this IoT device, they will know a lot more about their product. So they will know that which features that the customer will use it, where and how long your customer actually use this product, and how frequent they use it, why they use it, how they use it. So by getting a connected device, connected product, you will understand your customer more easily, rather than you have to go and ask them to fill in the questionnaire, the survey, and all that. Now you know better. So when you understand about IoT, to deploy IoT also, there are different phases. It can be very simple to very complex. So if you have tons of money, you can go to the fourth maturity level. But there are four maturity levels. The first maturity levels is all about monitor. So monitor is the simplest way to monitor it. The second maturity level is that when you want to control things, the ability for you to control. The third part is when you have a lot of data that you collect from sensors, you have the ability to optimize. And the fourth part is when the things and other things are connected to each other and talking to each other, exchanging information, you become autonomous. So let's give an example of any vertical. You go to any vertical, you can go on these four phases. So for example, in the area of like the vehicle industry. The first part is when you talk about monitoring, right? So vehicle monitoring, you have a sensor, a GPS can tell you where your car is. So that's the simplest part. And once you have the car, you know the location of the car. And when your car gets stolen, that's the second phase. If you put in the control part, the element of actuators, it can control your car by immobilizing the car, stops the engine, yeah, and even lock the car, so automatically. So that's the second phase of active maturity. But the third phase, you remember, when we have enough data that can collect information about the vehicles. So then you have enough information to tell the wear and tear of the car. The fuel consumption, the battery, the temperature, the engine, the tire, everything about the car you will know, and where the car goes every time. So it can automatically tells you the best route, can save fuel. Whenever you want to send for service, you don't have to send every 3 months. You know with the wear and tear, you can send it later or earlier depending on the condition of the car. And of course, your car manufacturer or the workshop will alert you when it's required. to do a service. So, but when it goes to the fourth level, the maturity level, where it's very the utmost highest part is the autonomous part. When the car is talking to each other, or the car can even talk to the infrastructure or the traffic light or the surrounding, it tells you that's when the car can drive by itself. So this is what we call autonomous car. So self-cruising, self-sailing, and all that. But remember, before this, there's a lot of things going to happen, and it will disrupt the whole business. So even when you deploy IoT in different places, it disrupts many businesses. So businesses, for example, technologies like this can disrupt a lot of things. Remember when Uber came in to Malaysia? Now it's Grab lah. So okay, okay. So when Uber came in, it's a very disruptive. When they thought that only the taxi driver, the normal taxi driver, can become the taxi driver, and suddenly Uber, Grab is when everyone can become a taxi driver. So it challenges, it gives, it does disrupt the whole business of taxi. So they were caught by surprise, and they don't like the idea, by taking their territory and young businesses. So that's what happened. But then you got to remember, when the taxi become driverless, autonomous, there are no taxi drivers at all. There's no taxi drivers. So all of them going to be jobless, right? So this also another disruption is going to happen to them. Okay. So what happened when even uh, even the autonomous taxis, autonomous vehicle, there are different challenges too. Okay, it's not that easy for us to deploy such automation. So there are 5 levels of automation, and from no automation using manual sort of thing, which is very old IR 1.0 to the IR 4.0 thingy. So when you hand over your control to the car, or either conditional or full automation, that's when the challenge come in, the intelligence parts come in, the third and the fourth and the fifth part. Remember, when you just drive, you just press a button and you just drive by itself. And you have seen the new Proton that can park by itself. So it's quite intelligent, right? So that's good. So on the fourth level of automation is when you drive a car or a vehicle, you still have a steering wheel in front of you. You can still hold it when there is something happen. You can need to hold it. So in certain countries, they require you to have a steering wheel, even though it can drive by itself. But when it goes to the fifth level, when it's very totally autonomous, you don't have a steering at all. You can't hold anything. It drives by itself. You can enjoy yourself inside the car. So, but then it also poses a very big challenges, right? Pose a big challenges. So what happened? I give you an example. Uh, what happened if you allow the car to make the decision? eh? So this is where your research coming in. When you allow this car to make decision, and when you are driving an autonomous car, and this thing happened, the car suddenly cannot brake, and is swerving, and it have two decisions. It either turn to the left or turn to the right. Okay, so when it turns to the right, it will hit group of children. Maybe 4 or 5 of them will die, or one of them will die. Or you turn to the left, you will hit old man or woman, a group of old men and women. They will die. And then they will have maybe a third decision, either left, right, or just straight. It will hit the wall and you will die. So the question is, what is the car's decision? Either you want to become a hero, you hit the wall and you will die, or you say that the old man lives too long already, just hit the old man because the kids are still have a long time to live, so to enjoy. So you do you take the car take the decision to the left. So what happened when you go to the court, you know, and you said that, the court says that you turn to the left and you hit the old man, and the car driver said, the car owner said, I don't drive, I don't drive. And the car manufacturer is the one that responsible. So the car manufacturer will be calling and they will ask, are you going to be responsible? Then the car manufacturer, the owner will say that no, it's because the person who programmed the car is the one that responsible. So how do you build ethics inside the car? So different ethics. different countries have different ethics, right? Malaysian drive differently compared to Singapore, compared to Thailand, compared to Vietnam, compared to Saudi. So they have different way of traveling. So that's why I think, like Dr. Zaha mentioned earlier this morning, when you have enough data for Malaysian, you might not be same data that you can implement in other countries. So what if you have that ethics built in into Malaysian car, but when you go across to other countries, what happened? Is it going to change to different country car, different countries' ethics? So it is very challenging when you have that full autonomous car. Okay, so that's a challenge. So I've seen there's a lot of questions here that, okay, I will answer that later, right? That's good. Thank you. Thank you. Okay, what happened when you have a flying taxi? That again changes the whole paradigm of business because you no longer have a what driving license. You might have a pilot license, or even the flying taxi doesn't have a pilot program. And taxis have also certain challenges too, technology-wise, maturity. The battery for this one can last for 30 minutes. So whenever you want to fly around the places, you have to fly around less than 30 minutes. Otherwise, just dive down. Okay. So taxis also pose a different way. It's going to disrupt the taxi business. That's why the reason where a lot of new things when being implemented, when introduced to other countries, to your countries, we need to have a trial. The trial is required four things. The first one, as I mentioned, is about technology maturity. You know, a battery that can last 30 minutes. Is that all? Is that only 30 minutes that our transportation? The market adoption. You know, people when you are when you are trying to ask for call for a taxi and then suddenly the taxi stops in front of you, there's no driver. Do you think the woman will take that kind of taxi? You know, so the market adoption, how the people use it, you know, and then the business model, how are you going to charge them? Is it going to be based on subscription based or outcome based? Because the new model of IoT is what we call outcome based. Outcome based means that if I want to take a taxi that can arrive in Kuala Lumpur just within less than 30 minutes, guaranteed, I'll take a flying taxi. If I cannot guarantee, then I'll take the normal land taxi. So that's how it is. So it's an outcome based. Okay. And the fourth part is that the policy and regulatory. So autonomous car, flying cars really pose a very big challenge to the regulatory body because even when even when this Digo, remember, like in Malay, in Kojak is in motorcycle sharing, it's Indonesia. Everyone can take the motorcycle and can ride share. In Malaysia, at one time, Digo, they failed to get the license because was not regulated. There's a new that we cannot use the normal motorcycle to drive people to make it as a business transportation. So that's why you need to change it. Yeah. So when the car is driving without any driver, it also changed the whole the law, the regulatory. So it needs to change. And when you want to fly, it's only last time it's only aeroplane. It's not like normal drones and all that. So drones have different routes and different height to fly. So can you just fly a drones without any pilots automatically? So in certain countries, you still need to have a pilot to see the drones. You cannot just out of sight. Drones cannot fly near the airport, near the pylons and all that. So there are many things that needs to be taken care of. So that's why in Malaysia, we have this National Technology Innovation Sandbox by Futurize, that these new technologies that we want to know about how it impacts the business, how it impacts the regulatory, can do this in that closed compound. Yeah. So when we want to do this IoT, also there are, it's always about data. So the kind of data that we want to get is different kind of data because data can come in many forms. It can come from various places too. It can come from the land, the sea, the air, all that. So it can generate a lot of tons of data. So the data can come in many forms. It can come in big volume, big or small volume. It can come in variety, text, video, or audio. It can come in velocity, very fast or very slow. It can come in various city. You are uncertain what kind of data that comes in. You cannot verify it. So when you have tons of data like this, you need to do big data analytics. So that is a different topic. So data itself, people say that once you collect the data, data is a new currency. I would say data is oil, but I would say data is black oil. Unless the data that you collect, all the symbols, the bits and the bytes, the numbers can be changed to something meaningful. You can you can answer the question of who, what, where, and when. It's become information. That's information technology. When you can answer the questions of how, it become knowledge, the knowledge technology. When you can answer the question of why, it can be purely understanding. So the higher it goes up to the level of the pyramid, it become more valuable. So the highest part will be wisdom. That's the human part, where it combines with the wisdom, with the emotion. Now that which machine still unlikely to have that now. Maybe in the future you will see, like, people like talking about Terminator and all that, that kind of very futuristic. They might have some wisdom, that robots have wisdom. So that's different. So data, when it comes in different part, you have to understand who owns the data. The data that comes from your machines, your device, it owns by you. It's personal. When the data is very private, by the company, you cannot share it out. The data from the government, the public needs to know. It's very, it's given to the public. But if no one is giving this or wants to share the data, then you make it commercial, where you can have someone to become a commercial sensor IoT provider who collects the data and he can sell the data out. Okay. So now, okay. So from there, if you want to do any applications, you want to collect the data, you must ask the right questions first. Otherwise, you collect tons of data and 90% of the data will be discarded, useless. So you don't want to spend your data storage so much, because you are taking data which is not usable. So first, you need to ask the question of just now, which I mentioned to you, the who, the what, the where, and when. So ask these questions. When you want to implement smart parking, you ask the question, is that the question that you want? Who park at my lot? What kind of vehicle? Where is the parking lot? When is the parking period? Because just having a stating that the parking lot is empty or full is okay, but like I said, it's only black oil until the black oil turns into information. So the car is being parked by someone when. So that's the question that you want to know. Or if the parking operators, he wants to know how to implement a tiered charging mechanism, so they can plan it out, getting the trends. I can even charge the person who are overstayed, and they want also to know that why is my parking utilization is low. So these are the parking operators concerned. So they want to have that kind of data. So any applications that you want to build will have this pyramid. So the idea of an IoT platform is also can help you into blending the IoT data. Blending in the sense that every vertical comes in with different sensors that can be used by application developer. So for example, there are application sensors that from home, waste, health, transport, and office. But if you can blend different data on a single platform that can collect the data, for example, uh, let me say home, health, and transport. Home, health, and transport. So you have a health wearable device, okay, health wearable device, which you stay at home, and suddenly when you fall down, your home will send, your device or your home can send an alert to the hospital. The hospital will send the transport, and the transport will know exactly the best route, which is not congestion and all that, to arrive to your place. So something like that. So waste, health, and transport. For example, you have a garbage bin which is so full and it tells you it's unhealthy. You send the information to the hospital, and the hospital, because of the waste, you might send to the municipal, and the municipal will send the right garbage truck to take your garbage. Right? So once you have that platform, it can blend and create many kind of applications. So for example, like us, okay, a few more minutes. Sample like us, for example, that's where we play a role. Favorite or favorite IoT uh, have a platform that can assist you on that. So this platform can connect many kind of sensors, which have different protocols, as I mentioned to you, either REST, MQTT, or CoAP. So either you can send directly or you can send through a gateway. And this data are being stored and manage the device through a platform. So in order for you to extract the data out to create your own applications, we have an open API that you can extract the data out and create the applications in. So it is to make you easily. So people have done this from months into weeks and weeks into days if they're familiar with the platform. So a lot of times people want to build it, they have difficulty to do a rapid development and showcase it so to the end users. So because it's running on cloud, so you don't have to worry. You can start with a very small number of devices and you can scale it big. But if you want that, we also provide that onto the on-premise. So to ease your data collection of data. Sometimes you want to make it private. You don't want to make on the public network. So it depends on how you want to do this. So there's a lot of tutorials, videos, sample codes that you can check it out and try it out. Right? So there is a QR code that you can scan and you can test it out. So at the moment, what we have about more than 106 countries. I think now today we have reached about 3,500 IoT developers, and about 75% of them are Malaysians already coming on board and become the generation IoT. So what we want now is more and more people to be aware of how to build an IoT solutions so that you can collect the data from many places. So this is my last slide. So what we want to see is that as a uh, as a user, you want to do this. You want some of us are the innovators. They like products that comes from the innovators. Sometimes you look at when you buy iPhone, even before the iPhone goes out, uh, tomorrow they will launch, everyone is queuing up. So these are the innovators, but the first one. So you be the first, or you want to become the early adopters, right? The one that start to buy the products when others already started. So there are times when it become the chasm because people it doesn't have enough traction, enough volume. Or you can go across the chasm and become the early majority. But we don't want because technology comes in that cycle. Yeah? It matures, like for example, the cellular network, like 10-year cycle. In the fifth year, it becomes peak. It's matured. So then it goes down before the new technology, new generation comes in. So you don't want to become late when the 4G is already, everyone is using 4G and you only want to embark on 4G because the moment you just use your 4G, people already start your 5G. So that's how we don't want you to become the late majority. We don't want to become the laggards that late in the market. So how do we start? It's quite easy. So it start by developing a small and very focused solution that have very immediate impact that you can see. You can get a buy-in. You can integrate that to your legacy system because at the moment maybe you have separate, but then you integrate to legacy system. And maybe the last one, you can innovate it by getting new workflow, new business model, new insights, or new analytics to be incorporated there. All right. So thank you. So if you want, you can join this IoT community. You can subscribe it for free if you want. Ask these questions. Humans make machines intelligent, not vice versa. Okay, if humans refuse to make machine intelligent, then no worries of job loss. True, but that is because the intelligent humans that program the machine intelligent, but there are certain people are not that intelligent. There are certain people are still not that intelligent. So this is where the machines will replace them, unfortunately. Or sometimes it's not about intelligence itself. Sometimes it's about things that you can't remember, things that you want to have fast response and all that. So humans tend to a little bit longer, but they have some emotion where the machines cannot able to replicate that, right? So Nur Fikri asked this question. Since most organizations are moving into automation, will AI in the future replace almost everything or every jobs? Will non-IT people lose their jobs or unable to get jobs? Should the human jobs be fully AI, or AI should act as an assistant for human to handle their jobs? So if you see machines, robots have artificial intelligence then, right? And robots themselves have this different kind of robots. You have industry robots, you have service robots, and now we have what we call cobots, the collaborative robots. The robots and the human are working in each other collaboratively. So sometimes you need the machines to help you, and the machines need you to make decision too. Okay, so that is become collaborative. So in that way, we also see that there are certain elements, as I mentioned to you, where the heart is not there, and the creativity part is still have machines have that difficulty to replicate that. So that's where jobs which is have emotions, heart, creativity will have difficulty, interfacing with humans and other that they have difficulty to replace this kind of jobs. Yeah. So, but when it's talk about doing dangerous things, doing difficult things, doing dirty things, that's where the robots will take the role. Yeah. So, so you will see on defense and all that, there are robots that can actually replace that because it's a very dangerous job. You see robots or machines that take the role of going to the nuclear plant when there's disaster happen. So that would be machines. You need to have machines that go into very dangerous places and all that. So you need that machines to take that role. So of course, rather than you send people, which is more valuable, so you send the machines to replace that. So we are replacing that kind of portion, that the kind of jobs that you're seeing now. So not all, but some of these jobs will be replaced. So another question, how to be confident about such driving cars in terms of cybersecurity attack? Imagine you are riding a self-driving car that is being hacked and controlled by a hacker. That's a good question because security is one of the biggest challenges that's facing when everything is connected to the internet. And of course, security can come in many levels. If you look at the whole 7 layers of open system interconnection, OSI, there are 7 layers. What we call that from physical, data link, you have network, you have transport, you have session, you have presentation, you have application layer. All these layers in the data communication, the computer communication part, requires different security levels. But sometimes there are one of the layers, although you make it very secure in terms of wireless, the communication, the TCP/IP, the internet part. The weakest point can be the application layer, where people can easily hack and get the password. That's the difficult part. So the password setting and all that is because of human too. So that's where I think human and some of the elements that they use to encrypt the password. That's the problem part. Of course, we are still open to that. There's a lot of research going on. With IoT, they're also looking at botnets attacking the IT infrastructure and stopping and jamming the whole system. Okay, you're right in that, but people are working very hard on towards that. Okay, if you don't mind, can you share why do you come up with the name Favorite? Okay, so a good question. Okay, Favorite is about 2017 when we started off the business, and we tried to find a lot of names, but we want to maintain the word IoT inside there, and we try to see what kind of domains are available that we can use. The .com company, and then we found out of all the lists, we found out the Favorite is one of the things. And because of the nature of the business, when we started off the business, is all about helping senior citizens. What we're saying is that we have this product called Rakit. The aim is to help senior citizens who are living alone at home. No one's going to take care of them. If there are emergencies, what's going to happen? So their health can be deteriorated without no one knowing, and when there has emergency, no one wants to quickly assist them. So we have that idea of uh, providing a solutions, helping them by wearing a wearable device. So what we call Rakit. So Rakit is this. So Rakit is just like a normal watch, a wearable watch. So it has parameters like health parameters, blood pressure, ECG, heart rate, steps, and all that. So it measures the health of the individual. Okay, so the health of the individual, and then they have this ability to monitor them from remote because it has cellular GPS, so you know the location. When the old people go out, the children will know when they go out because we have geofencing. So it's all about IoT. So when they go out, when they come back, and the children will know when they come back. So then we expand this to market like going to Hajj. People going to Hajj for pilgrimage. You want to monitor them from remote. You want to know the health of your spouse and all that. And when you are lost, you know where to find them. So that is about caring. It's about favor. We are providing solutions. Favor. So favor is providing favor to the people. So that's why the word favor IoT comes in. So we are partnering and helping people, assisting them. So now the idea is for us to IoTize in the sense that IoTize the business. Everything your business will be in IoT. So that's the reason why we call the name favorite. And the color, if you take a look at the color, why it's a magenta, is that uh, the word favor means kindness, and the color of kindness is magenta. That's it. So that's how we build. And okay, here's another question. Can you explain briefly about the beacon technology? I'm not the expert in beacon, but what beacon does is that it's a small device, but the way that it connects to the infrastructure is through Bluetooth. The current way is Bluetooth 4.0, now Bluetooth 5, I would say. So Bluetooth is the current way is much easier for them to connect to the gateway. So whenever you are near any gateway, it will detect where you are because the beacon also comprises of an ID which is attached to the beacon, and the beacon can be attached to any assets that you want to monitor. So when you are around that gateway, it sends the beacon out, the signal through Bluetooth, and then it will tells you the location where the asset are. So this is about a lot of asset tracking. So it's cheaper, less power, uh, and it's mobile. Of course, if you're out of the gateway, then you're no longer able to track them. Okay.